Hello class, welcome to this video on 5.3 review. So let's go and get started. Problem set number 1. So students in an urban school were curious about how many children regularly eat breakfast. They conducted a survey asking, do you eat breakfast regularly? All 595 students in the school responded to the survey. The data is given in the two-way table below. So define event F as getting a female student and event B as getting a student who eats breakfast regularly. So find P of B prime and describe this probability in words. All right, so P of B prime. This, remember, the B prime means, or it means B complement, so not B. So in this case, how many people were not eating breakfast regularly? So that's going to be these people right here, which is 295 out of 595, right? We got 295 out of 595, and again, don't forget to do that as a decimal if you don't want to reduce it. Okay, so 295, 0.496 if you round it to 3 decimals. So describe this probability in words. So in this case, the probability of randomly selecting a student from the school who does not eat breakfast regularly is 0.496. All right, so that's in words. So part B, find the probability of female and does not eat breakfast regularly. So how many students don't eat breakfast and are female? So we got yes, or so there are 100. So out of these females, 275 of them, there's 110 that eat breakfast regularly and 165 that don't. So we got 165 females and non-breakfast eaters divided by 595. Okay, of course we gotta do the calculation for that. So we got 0.277. All right, so now we want to find the probability of female or non-breakfast eater. So remember, in order to do this, you need to use the addition rule, the general addition rule. So it's the probability of females plus the probability of non-breakfast eaters minus the probability of both. And we just found the probability of both, so we don't have to do that again. The probability of female, and we just found the probability of non-breakfast eaters over here, so I could just use that there. Now for females, let's do the probability of female over here. Well, not there, let's do it over here. So the probability of female. How many females are there? Well, there's 275 females out of 595. So actually what I'm going to do is I'm going to just plug these results in. I'm going to add them all together and then we'll get the decimal, okay? So 275 out of 595 plus the breakfast eaters was 295, the non-breakfast eaters, minus the ones that are female and non-breakfast eaters, 165 out of 595. Okay, and so we just add the numerators. So we have 405. Okay, so 0.681 if you round it to 3 decimals. Okay, so that's for that one. This is for part B. This is for part A. All right, so that's how you do that one. Number 2, a standard deck of playing cards with jokers removed consists of 52 cards and 4 suits. Each suit has 13 cards with denominations ace through 10, and then jack, queen, king. The jack, queen, king are referred to as face cards. Okay, There are how many hearts? Well, there's 52 cards and there's 4 suits. So that means 52 divided by 4, that's 13 heart cards. And then there's 52 cards in total. So this is 39 non-heart cards. And then there's 3 face cards per suit, so 3 face cards that are heart. And remember that that means that there's 10 non-face cards, so ace, and then 2 through 10. And then keep in mind that for the non-heart cards, there's a total of 12 face cards because there's 4 suits. So there's 12 face cards in total, so that's 9 for non-hearts. And so there's 40 non-face cards, so there has to be 30 for non-heart face cards. All right, so that's the two-way table. Now we want to find the probability of H prime. Describe this probability in words. Okay, so the probability that we do not get a heart. Okay, so non-hearts. So how many non-hearts are there? Well, there's 39, right? So it's 39 out of 52, which if I divide by 13, top and bottom, that gives me 3/4. So 3/4 is 0.75. So there is 0.75 probability of randomly selecting a non-heart card. All right, so find the probability of a face card and not a heart. So probability of face card and H prime. So non-hearts and face cards. So that's got to be this one, non-heart and face. So there's 9 of them. 9 out of 52. If we divide, well, we can't divide by 3. So let's just do this as a decimal. 0.173. Okay. 9 out of 52, you can't reduce it, so it should be good like that as well. Find the probability of face. So the probability of F union H prime. So that's the addition, the general addition rule. So probability of face card plus probability of H prime minus probability of F and H prime. That's the general addition rule. You just got to know that rule. So the probability of face cards, there are 12 face cards out of 52. There are 30, how many non-hearts? There's 39 non-hearts out of 52 minus, then you want to subtract what they have in common, so face cards and non-hearts. So face card and non-hearts, that's 9, so just subtract that. All right, so we got 12 plus 9, or 12 minus 9 is 3, 3 plus 39, that's going to be 42 out of 52. And you can reduce that by dividing, but you could probably divide by 2 or something like that, and that might work. Let me see. But let's just do it as a decimal, so we don't have to worry about reducing it. 0.808. Round to 3 decimals. All right, number 3. How's the hatching of water python eggs influenced by the temperature of the snake's nest? So we have the hatching status for various temperatures of eggs of the nest. All right, so suppose we select one of the eggs at random. Define event C as getting an egg that was assigned to cold water temperature and H as getting an egg that hatched. All right, so the probability of selecting an egg that has hatched. There are 75, or no, we need to find the totals. So let's do the totals here. Okay, so let's get the total and the total totals. So there's 27 here, there's 56 here, there's 104 here, and then we can add those up. So 160, 187. This is 29, then that's 58, that's 54, 129. Okay, there you go. So we got everything now. So the probability of hatch. So there's 129 that hatched out of 187. Okay, again, didn't do it as a decimal. 0.6898, so 0.690 if we round it to 3 decimals. All right, so what's the probability of not cold water temperature? So not and hatched. Okay, so not cold water means neutral or hot, and it's hatched. Okay, so that's this right here. So that's 38 plus 75 divided by 187. All right, so that's going to be 113 out of 187. Let me double check that. Okay. 0.604 approximately. All right. So now find the probability of H prime or C. So again, union C. So that's the general addition rule. Probability H prime plus probability of C minus probability of H prime and C. And we found the H prime and C right here. We found the probability of we didn't find the probability of H prime, but we could do that. And we didn't find probability of C. Okay, so let's do that. The probability of H prime. So the probability of non-hatched eggs, that's 58 out of 107. The probability of cold, 27 eggs that are cold out of 187. Minus what we just got from, oh no, we actually didn't, this is not the same thing, sorry. I got the wrong idea there. So non-hatched and cold. So they're cold and non-hatched. So that's 11 out of 187. All right, so we got 27 minus, or 58 minus 11 is 47. 47 plus 27 is 74. Okay, let's figure out what that is. 0.396. All right, takes care of that one. So let's look at the next problem set. So this one is again using the general addition rule, based on no table or anything, just using the general addition rule, without a table, basically. So number one, a recent consensus at a major university revealed 60% of its students mainly use Macs. Okay, so let's say M is for Macs. And we'll say that so we got Macs and PCs. So we'll say C is for PCs. Okay. So what is the probability that this person is a graduate student or mainly uses a Mac? Okay, so 60% of its students mainly use Macs. The rest mainly use PCs. At the time of the census, 67% of the students' school were undergraduates. The rest with them, okay. Okay, gotcha. So it looks like we're Macs. So M is for Macs, and we'll say G is for graduate student. Those are our two events. Okay, so it says, what's the probability of graduate student or Mac user, right? So, again, using the general addition rules, probability of G plus probability of M minus probability of G intersect M. Now, it says here that the probability of a graduate, now they say 67% of the schools were undergraduates, which means that if 67% were undergraduates, right? So let me do that here. That means that the graduates is 1 minus 67%. That means 33% were graduates. So we can plug that into here. Now it says at the time of the census, okay, the rest were graduate students, okay, and the census 23% of students were graduate students who said that they use Macs as their main computers. So 23% were graduate students who said that they use Macs. So that right there is this number right here. They so that 23% is the intersect. And it says that 60% of its students mainly use Macs, so that's my P of M, right? So P of M, that's what that one is. Okay, so we got 0.33 plus 0.60 minus 0.23. So we got 0.33 minus 0.23, that's just 0.10, so this is going to be 0.70. So the probability that this person is a graduate student or mainly uses a Mac is 70%. All right, number 2, what's the probability that the student uses both Pandora and Spotify? So probability of Pandora, we're going to say N for Pandora. And S is for Spotify. Okay, so Pandora and Spotify. So they want the probability of that and that. Now, in order to do that, we know that we need to use the general addition rule. Okay, so we got the Pandora or Spotify. The formula for that is the probability of Pandora plus the probability of Spotify minus the probability of Pandora and Spotify. We know the probability, we're trying to look for this, right? That's the question mark. So do they tell us the rest? Well, it says here 82% use either Pandora or Spotify, right? So that means that's going to be this one right here, 0.82. This is that number. 68% use Pandora, so obviously that 68% refers to that, and then the 38% use Spotify. Okay, so 0.68 plus 0.38 minus the intersect. And so let's just do the math here. 0.82 is equal to 1.06 if I add that together, minus that. So the intersect is equal to 1.06 minus 0.82, which is 0.24. Okay, so there you go. It has to be 0.24. Let me double check that. .24. All right, there's your answer. All right, so number 3. In January 2010, 53% of U.S. senators were Republicans and the rest were Democrats or independents. 26% of the senators were females. 44% of senators were male Republicans. So that's the intersect that they gave you. Okay, so so M is for male. So R's for Republican. So they want the probability of male or Republican. So it's the probability of male plus the probability of Republican minus the probability of male and Republican. Now, 44% were male Republicans. So that's this number right here, 40.44. 26% were female. So that's the probability of females. Okay, so then the probability of male has to be 1 minus 0.26, right? So 0.74. So 74% males if 26% were females. 53% of U.S. senators were Republicans. Okay, so that's what they said right here. So that's going to be R. All right, so here we go. So we got 0.74 plus 53 were Republican minus male Republicans was 0.44. Okay, and we do the math there. So 0.83. All right, takes care of that one. So let's do problem set number 3, which is basically creating a Venn diagram and then finding the probability. All right, so it says construct a Venn diagram to represent the outcomes. Using the events T, dine at Taco Bell, and C, dine at Chipotle. All right, so we got T, C, and then we got the Venn diagram. Okay, so it says, remember the middle is both. So 34%, 38% of them had Taco Bell, 16% Chipotle, and 9% had both. So that's 0.09. Okay. And then, so now if it says 38% were at Taco Bell, so that means you got to do 38% minus 9%, so that's 29%. So 29 plus 9%, that's 38% for Taco Bell. And then Chipotle was 16%, so 16% minus 9% is 7%. That adds up to 16%. All right, and then we got to figure out how many do neither. So we got to say, okay, they all have to add up to 1. So 0.29 plus 0.09 plus 0.07, that's 0.45. 1 minus 0.45 is 0.55. So 55% dined at neither. Okay, so there's my Venn diagram. Find the probability that the student had dined at Chipotle but not Taco Bell. So Chipotle but not Taco Bell, that's 7% right there. So the probability of C and not Taco Bell is 0.07. And that's it. You get it straight from the Venn diagram. All right, fine. So now let's do number 2. This is the Mac example that we did earlier. So let's do a Venn diagram. So G is for graduate, M is for Mac. Okay, so as we said earlier, it says 60% of students use Macs, okay? So we got 60% use Macs. It says how many were graduates and, let's see, 23% were graduates who said that they use Macs. Okay, so you go, 0.23, which means that 0.60 minus 0.23 is 0.37. So that means this is 37% of users who use Macs, but are not graduates. And then they said that 67% were undergraduates. That means 33% were graduates. So we got to do 0.33 minus 0.23, which is 0.10. So this has got to be 0.10. That way this adds up to 33%. So this is, so now we got 0.10 plus 0.23 plus 0.37. So that's 0.33, so 0, 70%. Okay, so that means 1 minus 70% is 30%. Okay, so this is 0.30 on the outside. Okay, so that's my Venn diagram. So find the probability of G prime intersect M prime. So it's neither graduate nor Mac user, basically. So that's this number right here, 30%. Okay, we got it straight from the Venn diagram. All right, number 3, January 2020, 53% of U.S. So this is the senator example, the senator Republican example, or the the male Republicans. So say this is male, and then this is going to be Republican. Okay, so 53% were Republicans. So, and then it says how many were male? It says 43% of the senators were male Republicans. So that's going to be right here. 44% were both. Now it says that 26% were females. So that means 100 minus 26% is 74%. So 74% were males. But we got to subtract that from 0.44 to get the males that are not Republicans. So right here, so 0.30. And then there were 53% of the U.S. senators were Republicans. So we got 0.53 minus 0.44 is 0.09. So this is 0.09 Republicans that are not males. In other words, Republican females. And then add these up, subtract that from 1. And so 1 minus that is equal to 17%. So 17% were neither were neither male nor Republican. So they were female Democrats or something like that, or female independents, for example. And that's what they wanted. The probability that they were not male and not Republican is 0.17. All right, that takes care of that. Guys, I hope you found this useful and informative. And as usual, I'll see you in the next one.